Given a string s, return true if a permutation of the string could form a palindrome. So this is the string that is given to us, and we should see if we can form a palindrome from any permutation of this string. So what is a permutation? Permutation is like how I can move around the letters that are given to me in this string and make different permutation, different strings. So for code we can do this, or we can use this, or we can say something like this, and so on, right? Many different permutation. We should check to see if any of permutation of these string is going to make a palindrome. What is a palindrome? A palindrome is like a string that if you read it from left to the right or right to the left, it's going to be the same. So this is a palindrome, and for example, this is not a palindrome, because if you read it from left to right, it's going to be ABGA, and from right to the left, it's going to be AGBA. So now that we know the definition of palindrome and permutation, we can see that, for example, with this one, with AAB, a permutation of ABA, it's going to be a palindrome. Or for this one, the permutation of this a string is going to be a palindrome. The easiest way that we can do that, we can use counter from collections library. What we are going to do, we are going to make a dictionary of letters with the number of that letters that we have in the string. And the reason that we are going to do that, right, let's print this out so you see how it works. So the reason that we do that, because the number of letters, as you see here, for example, for code, if we have only one C and we have only one O and one D and one E, we know that we cannot make any permutation that is palindrome. But for example, if we have 3V and the number of odd alpha letter is only one, then we can make a palindrome. So what we're going to do, we are going to see if the number of odd letter that we have in this dictionary is more than one. And if it is more than one, then we can say it's not a palindrome. If it is 0 or 1, then we can say it can be a palindrome. So let's say what we're going to do, we are going to go through the values of the count dictionary. And we are going to check the value that we have, which is each value is for each letter. We are going to say if we divide it by 2, it's gonna be not equal to 0. And if it is not equal to 0, it means we have odd number of that letter. How we can keep track of the number of odd letters that we have, we are going to have a variable odd, and we keep adding to that when we see odd value of a letter. And then what we are going to do, we are going to check at this point, like right away, to see if the odd is bigger than 1. It means it's not equal to 0 or 1. If it is bigger than 1, we can right away return false. So we don't need to go through the whole dictionary. We can just return false here. And if not, we are going to return true. The time complexity for this is going to be linear, because we have to iterate. The worst cases, we have to iterate over every single values that we have. And the space complexity is going to be constant, because as you see here, we have the policy that the constraint that we have here is like the length of S is going to be from 1 to 50, and it's consists of lowercase. Thank you.